Hello. It is time. All right. I was not ready, actually. I was not fully prepared. I don't have Steam open, I don't have Godot open. I did do one thing. I'll show it. I fixed my search engine. No more Google. It's just like there's no way to turn off just instantly showing my GPS location on like if it just decides, hey, this search result could be vaguely connected to your current location, so let's just put that on screen. If you Google search what's my IP, it tells you your IP. That's fixed. I can just turn that off. Not on Google. But I've got it. And I'm going to demonstrate. That's how... Maybe I shouldn't be so confident, but... I will demonstrate it later. Because it's been really annoying, because I would like to just be able to search for something and not have to worry about... Like, there's been times where I'm like Google searching a bug, and for some reason that gets connected to a location, and then it just shows it. Very annoying. All right. I'm in. So I mean, okay, here's one thing I could do. Here's one thing I haven't really tried. I could just pass in velocities as it is. Like, just getting rid of this. And just not doing that. I haven't actually tried that one yet. And I've got a theory. I also have a bit of a theory. So... Okay, one second. I gotta turn my heater down. All right. These collision shapes should all be shared. And my thought is I probably just need to extend them down so that they're actually touching the ground. Snapping it on. So yeah, I should probably have it like about as close as I can really get it. Because if I need them to be colliding with the ground when I'm just gonna try to verify that these are all try to select the actual, what is this, middle left? Oh no. Why are the shapes not duplicated? Oh. Oh no. Okay. I understand what's going on. Alright, so I gotta turn off all the... I have to turn off all the shapes. And I have to verify that these are all correct. Every shape. So it's just that when I change the box like that, or when I change the collider like that, it updates the shape parameters on everybody, but it does not update... How did I miss a bunch of them? Because I just missed a bunch of them. Duh. And apparently I have a femur that's being shown. Gosh, this looks like a mess. This overview looks like a total mess. I don't need to see IK. Where's IK? Is it, I don't need to see joined 3D. I don't need to see. I must just be blind. Chain IK. There we go. Whoa. Oh yeah. So when I change the parameters of the colliders, at the same time when I click and drag the gizmo, I am moving the collider, but only in that one shape. I'm not moving it on any other shape. So that means some of these are going to just be misaligned with the bones. I need to turn the sky off. Can I just not have the sky? Can I change what the preview environment is? Are these on or off? Zero. There we go. I'm in the void. Okay, so this shape is the one I'm looking to copy, and I just need to like reset these. Yes, I need 0.84 copy value. And I gotta go to all. Hey, Yulia. That one already looks good. I guess I can just click like this. That was fast. I can see like the first message is always going to be quick because I notice it. This one's in the right. Did I already do all 6? 5? Sometimes it does get to a point where, like, if I look over and there's a message that is not something I can really respond to, or like I have to think about it, or even like consider if I want to respond to it, that's when I might just start totally ignoring messages. But I really shouldn't do that. Okay, these are on the right spot. Yeah, I don't know what I thought there. Is there a way to box? Wow. Poor number with no legs. I might have gotten it figured out. I just need to set velocity to like the angle. But I haven't actually tested pushing anything yet, so I don't know. Oh, here's an idea. What if I set... No, because values below 1 don't work like that. Alright, can I... Jeez. It's in radians. How could I even display this? Am I looking for... this? If this might be too much, I'll try that. I'll try square root. So if it's nearly 0, I'm gonna 0 it, but then after that, I'm gonna square root it. Can I just write that? Why don't they define that operator? Okay. I can't raise a vector to a power. Huh. What? That's just nothing. That's just not me. What was that? Oh. I forgot how square roots work. Like it needs to be way more reactive, but like how do I have the force limits turned off? I wonder if I really do have to have a spring that acts as like the grip, so when I'm in contact with the ground, it actually like pushes out and makes ground contact. Because otherwise I'm just resting the rigid body on there. What was he gonna do? I was gonna go here. No, I was gonna go here. These three open. Okay, what if I went back to 500? I mean, I guess kind of the issue is that it really does struggle to react. And I do, oh man. How can I get away without having this extra joint? I'll turn the Z back on. So I just delete this line. And I still don't understand what's up with the leg lifting. I'm like really confused by that. I don't know what that is. Because it kind of just like goes a little haywire and just continuously jumps up. What is that? It just like reached at me. I mean, I guess the most obvious thing right now is that there is a balance problem. It pretty much can't sit still ever. I think there's also just an issue with the legs. I mean, alright. Why would it not be able to sit still? I think it's probably not able to sit still because some of these legs are applying a ground force when they shouldn't really be applying a ground force. Alright. So I think I don't really want to add more springs, but I probably have to. My thinking here is probably I don't wanna. But what I think I probably should do is have a spring on each leg that when the leg says we're grounded, the spring will expand and contract and apply pulling and pushing forces. Which is going to sort of feed back into its own self-balancing thing, which I don't really like. But maybe that is going to be fine. Maybe that's going to be fine. But there's kind of a weird thing with that. There's no such thing as like an actual grip body, I guess, where it basically has to be my own kind of spring cast on every leg. Do I already have that? I have a shape cast, which is just for ground detection. No, this is for stepping. The ground cast is going to be ground detection. And I guess what I need to make sure I close that before I change the default. Can I render that? Debug a ground cast true. IK target rest. I already have it on. Okay, let me turn this off. And let me turn this off. And this one's tracking well, so I don't need to see that. Okay, so the ground cast is already happening. Okay, let me try a different thing here. This again. Let me try making it so that this ridge body is not really in contact with the ground. I don't know. There's a thing happening here. I would like this to not contact the ground. Or at least I want this to not push off the ground. If it ends up pushing off the ground, I want to stop that. You know what? There's also stopping friction. Haven't I turned off stopping friction on the robot? That might be why it struggles. Because it actually has no stopping in its... Okay, let me start with that. Desired surface friction 0. Let me think about this. Desired surface friction is positive. So I need to... Let me try something. What if I just have this be like a less than 1 value? It is only used here. What if I just set this to like 0.9? I'll just try a slightly less than 1 value. Okay. And the dog is barking. Yeah, so here's still an issue. It's doing this thing all the time. Okay, hang on. All right. Let me try 0.5. I mean, it's still the issue that this vector is just kind of exploding and just going like this, right, all the time. Right, like... Also, the vector is supposed to point in the direction that it applies in, which means right now it should be applying precisely opposite to movement on the next tick, but it's not. It's not doing it right. So like if I were to hit this button, it should be pointing, like why is it still pointing towards me, right? The whole thing is shaking. So what's going wrong there? Okay, I'm just gonna put a breakpoint there and see what's going on. Yeah, so it's kind of doing this thing where this vector is definitely pointing towards me, and then this vector is pointing in the same direction as velocity, which means we're actually accelerating in that direction. So I skipped that one. What? Wait, where is this? Wait, who is this? What do you mean this is the stack? What character is this? Okay, this is the crawler. Alright. So currently my ground direction is 9.8 on the X. So almost entirely this way and slightly forward. So it actually looks roughly the same as this green vector, which I know is pointing towards me. Roughly the same. Which means it should point the opposite direction exactly. Well, what is ground friction right now? Ground friction already has a value, which is pointing me in the direction that I'm currently traveling. Why? Ground friction is already pointing me in the way that I'm traveling. Ground friction. Is this not being zeroed? I'm not zeroing ground friction right now. Okay. I don't know why I'm not, but I should be. All right, well that's an immediate obvious problem, I guess. Okay. Okay. Let me set it to the max. I guess not the max, but like really high. Wait a second. shouldn't I be applying it in the ground direction? Like, ground relative contact velocity should be pointing the same way as ground direction, right? So I check ground direction. Ground direction is not calculated here. Oh. Should be calculating here. So ground direction should just be relative contact velocity slide up. Okay, so it's not. Oh, you know what? Maybe I do. Calculate ground vectors. Custom pre-movement. I think I know what I should be doing here. I think so each leg should be applying friction at its location. Which means if it's in contact with the ground, it should be applying that opposing motion force to the body at that location, which means it's going to be changing. It's going to be changing angular velocity and all that stuff here. So this also apply angular forces here. I apply them there. Why? I guess it's because I can, because I don't read them anywhere else. I think what I really want to do is actually calculate them here, calculate a total angular velocity change, and then and a linear velocity change from friction, and then deal with that. It's a lot of forces happening. So what is this? Spring force. Body height, spring stiffness. Body height, spring damping. Offset. Leg ground offset. Do I calculate that here? I do. Should I instead call this like solve leg forces? Maybe I should call this solve leg forces. And then the idea is that I would come in here and I would do this here as part of everything together. But this also does a lot of work to try and avoid changes to angular velocity. I'm going to drop this line. I really don't know if this does anything. Then solve rotation. Like, I mean, the reason I think I should take that off is because of this. These should be applying rotation to the body. I think they probably should be. Is there a way I can, like, easily turn off the physical skeleton? Maybe I need to set that up, that I can have a switch where I just turn it on and off. Okay. I'm gonna do this. I'm gonna add like a boolean that I can turn on and off to enable or disable it. I don't think I can go so far as to set up like should I? Yeah, sorry. Let me finish the sentence. I don't think I should go so far as to set up so I can turn it on and off while it's running. But if I can at least turn it off and run it and see it working without physical and then turning on physical, and the idea is that I want those two to match as close as possible. And I mean, really what I actually want is, let me remind myself what I really want. I just want it to be possible that if I throw an object at the leg, it will hit the leg. Maybe it would just be fine to not even use motors. Oh no. Okay, I sort of just had a realization that because of, like, literally, I just remembered that momentum exists. Even though, like, say the motor on this side goes up, or, what I'm trying to say, extends like this, this actually causes the motors up the chain to now have an impulse to counteract. Which means they're all basically always going to be rotating a little bit further than they mean to. I guess there's a way to anticipate that force, right? I can start at the end of the leg, calculate the velocity, then calculate I mean, because, okay, so essentially what happens is when I tell a motor to rotate, I'm not just saying A, B does this, right? I'm saying this change. This is the change that I'm actually making, which means that might be like the big realization here for a problem. Okay, first thing I want to do, I'm going to make it so I can just turn these off. But I have some changes here, which means I probably need to go and like commit something. Because I just have a lot. Yeah, I just have a bunch right now. I think that's exactly it. I should be able to use inertia calculations, because basically what happens is the end leg, and I guess I probably do this as in terms of like iterations as well. Basically, depending on the shapes of the motors, if I were to expand the end joint, I would contract that inner joint. In fact, that's kind of always what happens. If I contract the end joint, I'm expanding the inner joint. So I need to account for that. So when I calculate my velocities, I should probably start from the end of the leg. I calculate the velocity there. And then I calculate oh. I calculate it should be like an anticipated velocity of the next motor up the chain. And I guess also the motor, like basically all the way up the chain, I guess. I need to sort of, I don't think an iterative process is necessary. It might be as simple as just going sort of up the chain and then back down the chain. And that would probably be precise enough. Yeah, because I mean, what it really means is that, yeah, if I apply an angular velocity at that motor point. Okay, there may be a cheat code. There may be a cheat code that I could work into this, because anywhere that I can cheat to save on calculations is going to be preferred. Basically, what I would want to do is have some sort of switch that says apply the forces only to node B and ignore node A. It makes it non-physical. And actually, that's probably just not a good idea either, because then a collision on this joint that pushes in is not going to run up the chain anymore. If I'm only applying forces, if I'm treating body A as static and node B as the full body. Which is exactly how I would implement the cheat code. Okay, I'm not going to do it. What I'm going to do is it should be a simple calculation. I just start at the end of the chain and run up the chain and then back down. But it does mean that I have to worry about a chain now. Which means more things to track. Essentially, a joint data needs to be a doubly linked list, which isn't so bad. I mean, that's exactly it, though. The solution, there is a theoretical solution, which is... Okay, close that. I think this is where a realization of, like, I gotta crank up velocity steps or something is probably happening. Or why that worked is because I say motor A set your velocity to this value, but that has an implication on the next node in the chain, which means it's going to inherently apply some velocity to that one. But if I'm applying what I know is like a really, really good motor velocity already, it should already be in like a good spot where it's going to apply this velocity. Wait, actually it may not be enough. Let me think about this. Because if I calculate, okay, if you set the velocities of all these motors to this value, we're going to be balanced. What's going to happen is when it actually runs that, it's going to set the velocity of this one. That's going to update the velocity of this one. which means the let me think about that. Okay, let's say I have a fixed point on a wall. I'm gonna diagram. Whoops. I just need to know if this is actually going to work in practice, because the theory is that I just say, hey, yeah, set the velocity and don't worry about feedback. But feedback is going to happen in that system anyway, and then it's going to try to balance out to make sure that the nodes are all hitting that velocity, which they're not going to, because they're going to feed into each other again. Oh, maybe not, because if I know the velocity I'm setting to, if I start at either one, I'm going to say, hey, set yours to 5, and this other one should be set to 10. I set 1 to 5, and I calculate that the feedback is going to cause the other one to be like 8, right? So then it goes in and says, oh, we need to be at 10, so let's go to 10. And the other one's going to be a little bit over 5, so then it drops down a little bit, back to 5. And basically it's just going to run through the iteration and kind of like realize that its input values should have, I mean, that's an idea for like why it probably might work. Let me make that. Okay. So I've just got a wall. Is the idea. And I would have I don't know what color. Orange. I don't know. Why does it not even look very sharp? Shouldn't it look sharp because I'm on a vector layer? Or whatever. Okay. Let's do blue. Segment 1. Segment 2. And there would be a motor here and a motor here. So the idea is that maybe let me just do another one. So the idea is that I would have a target here. Okay, let's just say that the orange one is my target. That's where I want to go. So what I discover is that all I have to do is apply, and these two beams are the same length, the same mass. is I need to apply a velocity of, I'm just going to say this is 1 degree or whatever. I don't know. I apply a velocity that results in this segment reaching its target in a single tick, right? However, this is applied as like an opening to both sides. So what happens is this one is actually going to get a velocity that's going to rotate it like this. And this one's going to get a velocity, or actually, hang on, sorry, this is opening, right? So what's really going to happen is the result of this would be, I will duplicate this layer. Do like an onion skin, I guess. What will actually happen is this should, hold on, is this should rotate down like this, and this will rotate up like this. And then the motor is here, right? That's what would really happen. So as you can see now, this motor is closer to having the angle that it wants, but now this one is really far off the angle that it wants. Which means the overall interior angle has become what I want it to become. But I've basically applied an angular velocity on the next motor up the chain that counteracts, that has changed its offset. So what I should do is once I calculate this one, and this is why I think I should start at the end, because the end has no more joints. I start at the end, I calculate the changes, and then I also determine, I know that technically the angle of this joint, I'm just going to assume the angle of the joint is going to reach what I want it to reach. But how do I calculate what the offset becomes for the next motor up the chain? I suppose I can think of it like this. So when they change, I'm just going to worry about angular rotation and not positional changes, because positional changes actually get corrected on the next, actually get corrected later. So basically I think I just kind of do this. But then I need to take this whole setup and rotate it so that we're like more like halfway. So these two angles have kind of changed like this. And then these would then actually, yeah, these would actually kind of be like this, right? This is where everything would end up after that velocity step. And I'll just keep the joints like roughly where they're supposed to be. Right? So this is what would happen. I guess what I can do is yeah, because then what a position correction would do is it would say, let's move this one back a little bit, let's move this one back a little bit, and then it would say, all right, well, this one needs to be aligned here, so let's move this one back a little bit, let's move this one a little bit, right? So I guess if I were to like really just kind of, you know, put everything back to where I know it should be. This may not be exactly right, but and then just to be sure, I'm going to rotate the whole system back. So only this one's moved, and yeah, we're basically in the same spot, right? So this is kind of what would happen. What I feel like I notice is that this one's angle changed very slightly, but this one's angle changed quite dramatically. This could be a result of me just... I don't know, having imagined it wrong, but maybe this is right. So to me, what it kind of looks like is that basically the entire... Well, I know this is not true. Okay, well, I know this would only happen because I know this is a fixed point. Okay, let me backtrack this. Let me try this again. So this one rotates up like this. What I know should really happen is that half of this rotation is shared with this one. Well, actually, how do I know that half? Okay, what's the proportion? I guess it's that inverse mass, right? If I calculate the inverse... Sorry, the effective mass, which is just taking the inverse masses, accounting for any current angular velocities at these points, which means inertia tensors are going to be used, so it's going to account for the location of the point. And then that's going to be the share of angular change. Which I guess just means that I just apply that angle directly to the next joint. Think about this. Also, I wanted to see, did I have like... Did I need to remember which one I decided this should be at. I can't remember. It's going to be whatever's in the comment. Except lock that 16 velocity and 16 position. Okay, so that's what I mean to have. Get back to 16. Do I have it in a bug state right now? No. Okay. So I guess if I know that's the angular velocity change, could I interpret that as just doing a single step and saying, this is what the resulting joint separation will be? And I guess it's actually just as simple as just running a single velocity tick. Because if my angular velocity is like this, then that means, assuming that fixed joint stays in place, it's going to change by the exact angle that the exact angular velocity that I impart on it. Which basically means I can minimize... Oh, maybe this is the way that I need to think about it. I'm setting up all the velocities to minimize the error on the next step. So if this one's already at 0, but I'm going to move another joint, I technically know that I need to apply some force on this motor to keep it at 0. And I know that the angle... I guess here's kind of another problem. there is the middle section joint, which actually will affect two joints. Which, I mean, I guess is just me saying, if I run forwards and backwards, then that's probably good, right? Okay. All right. But I need to commit some things. Yes, this is just me starting on joint motors, is really all this is. I have two random lines here. Is there anything that I think I probably can commit right now? Okay, I'll be right back. I'm back. Actually thinking about this. No, okay. For some reason, I just had like a super critter. I just had a thought for a second that should I treat the next joint as basically being a static body? Which means it doesn't make any sense. But basically it would be to apply double the rotational force and then apply the opposite half of that to the other one. Something like that. Or like apply double the force to mine and then apply the opposite 1 unit of force to the next joint kind of thing. But no, that doesn't make sense. I think it should be accurate enough if I just treat the angular velocity that I'm applying, or actually just the velocity, in fact. Because the velocity of the motor is okay. I need to commit. I need to do a commit to keep everything clean so I know what I'm doing. And the first thing I'm going to do is I'm going to make it so I can turn off the physical skeleton and just see the crawler moving totally IK, or totally visual IK, no like interactions, and then turn on the physical skeleton and rerun it, and I should just see the same, very, very close to the same results. Screw everything up next. Yeah. I just need to see if I need to like split anything off immediately. Okay, my setup function was dumb. Yeah. That's all just part of the same stuff. That one I can... That one I probably just want to take off now. High friction. I'm probably just gonna undo that change. Or I don't know, maybe I just make it... Yeah, here, okay, so here's like a thing with... how do I make it so that something has not just friction, but like very specifically grip? I mean, I think all I do there is I just have like a spring, a custom spring force that just applies a pulling, which will bring body A closer and bring body B closer. It's probably all I do. All right, but I think I probably should increase what high friction is. I turned those off and I moved them. Which I guess I can just kind of send. That was weird. Yeah, how did that break like that? Weird. Just gonna double check the transforms. I don't have anything like a bunch of a value that should be 0, but is like really close to 0 instead of just being 0. Or a 1. It's like a bunch of zeros and then a 01 at the end. Increased high friction. I moved this one and then I turned off. In fact, I think I should just want to... Oh wait, I kind of have to fix player scale. Yeah, you know, let me make this... I'll turn this back on and I'll just move them somewhere else. Oh. That's actually nice. With this organization, I could actually set that top level node to be that. So that these are all pausable by default. Then they have to be on inherit. I don't know if it's even necessary for me to put it on pausable. Because I think pausing the scene tree stops physics anyway. What is this physics material? It's just low friction. Okay, Actually, I think I want to move them over here. Is it in the path of this? It's not. Good. Right, nice numbers now. And then characters should also be plausible. I guess I just set these back to inherit. Good. All right. Set nested bodies to inherit process mode. And then okay. That one's good. Everything else should just be my work on physical skeleton and doing some improvements there. Though I wonder if I can just send the crawler leg as it is. I need to turn the debug off. No, I can't because that requires a change at the top. Okay. And then that height value sucks. But I think I can fix it. Why do I keep clicking the wrong thing? Yep. Okay, cool. I was able to fix it. I have all this stuff. Okay. Add it all. Now I will really review it. I'm going to delete this commented code. Yeah, I actually have a lot of cleanup to do. What? Did I not actually save? Or what am I looking at? Yeah, that's what I just thought I removed. It's still there. Did I not actually delete it? What did I just delete then? Oh, I deleted the motor printing that. Okay. Then I delete that. Very confused. And then I have this like velocity stuff in the middle. Yeah, I'm going to just delete this whole bit because this is more like it to do. It takes me like way too long to get out of Vim mode sometimes. I'm like hitting escape and trying to like type :W instead of hitting Control S. Actually, yeah, hang on. Okay, let me focus here. No, maybe I need to explore that idea before I continue. If I apply an angular velocity here that will just reach this point in the next step, half of that rotation is going to be put into this one. So I'll just say like that, I don't know. And then the other half is going to be put into this one. Right, kind of like this. That's the distribution of the angle. So the interior angle is going to meet, but the problem is that I've adjusted this one's angle. So if I were to just quickly fix it, sort of, and then move it back into place. Yeah. So even doing the diagram worked out in that case. So that's what will happen. But then assuming all that we do is we just do... I mean, yeah, because once we do the position correction, this one's already going to be in place. So it's going to say, oh yeah, we don't need to position correct this one. Then we look at this one and we say, all right, we need to position correct this guy, which would basically just be to pull it down here. And then I guess we would do position correction on this guy, which will actually kind of do like this. It'll like move them halfway, right? And this one will meet. Essentially, the ultimate result is that this will just pull down here. Okay. So the interior angle matches, but now this angle is wrong. But I didn't rotate these at all. So I just know that whatever I apply here, the inverse inertia ratio of, I guess, or I guess I take the effective mass. I multiply that by the angular. I take that inverse. I take that effective mass. I know how it's going to apply. I can calculate exactly what rotation this one's going to take on. And the idea is that I want to negate that. Or I guess not really negate that, but I take that rotation and I add it to the angle error that... I add that to the error of the motor attached up the joint. I add it to that one. So then I get to this motor and I say, all right, our error angle is technically this big value now. So we need to correct for that, which in this case, because of how, because I'm only affecting the two bodies connected to this motor, I actually won't affect, okay, this is good. I actually won't affect this interior angle. I won't affect it. So what happens is, I mean, I basically will just take this entire system, and at this point, because I know that this, in this example, that's a static body, I would just fix for that angle by applying that velocity back here. Which it looks like they're roughly parallel now. And then the position correction would boot up, and I mean, you know, diagram's not perfect, but this is a lot more accurate of a result if the motors can incur the velocities that they need to have. If this was a triple joint, then what would actually happen is only half of that would go into this one. So if I undo, half it would go into here, so I don't know really what's half. I mean, it's actually such a small correction, really. And then this one would, if there was like a third leg here, this leg would rotate, sort of. And then I would come back down the chain and see this one would have an error, so I would fix for that. This one would still have an error, so then I would fix for that. And the idea is, at least roughly, after like maybe just an up and a down iteration, we're actually like really, really close to what the motor should be. Yeah, okay. Every interior angle still adds, you know, I guess a need to do additional steps to try to correct for it. Yeah, and I think it's not avoidable. You can only really approach the ideal solution because every time you make a change, you're affecting two other, or at least every time you're making a change, you're applying half of that correction to the other body. It will help in this case because technically this main body is, I don't know what I have it at, 10, I mean, I'm just guessing, but 10 times more massive than the piece that it's attached to. So this motor is like the last one in the chain, going up the chain. It'll basically apply most of its correction to itself. So then going back down, there's probably going to be like almost no correction anyway, because this one didn't actually change any other interior angles. It's actually specifically just this joint will have an effect on this interior angle. But it wouldn't really have an effect on this one. Maybe I only have to go up the chain. Because I actually... I don't know, I'll see, I guess. I'll probably... I guess what I should code it so I just go up the chain and then I don't go back down. Or I can set a switch to go up the chain and then back down, and I can see what kind of corrections am I applying going back down. And if they're like meaningful, which I would say meaningful is probably like anything higher than... I'd be applying angles and errors of like radians. Anything higher than probably 1/100th of a degree, I would say is probably meaningful. And it's probably worth going back down the chain to do that correction again. Maybe I just set it so I have like an iteration count. But every additional iteration goes in the opposite direction. So first iteration is up, second iteration is down, third iteration is up. That kind of thing. So I can see... I'm thinking it may be the case that I could probably get away with having a single going up the chain, or even going down the chain. It might actually not matter which way I go. Well, I guess it probably does matter, because it could be the case that... I've been thinking of the case where I have a single motor that wants to change its angle. If I have all 3 motors want to change their angle dramatically, it's probably it probably would require going up and then back down the chain. Yeah, it might be a case where I see that 1 iteration is definitely not enough. 2 is like 99% of the way there. And then I would just say, all right, well, if I just do 3, then it's going to be like 100% in the most extreme cases. Okay. It's storing the bone length. Does this need to have an error? Probably not. There's iterate IK3D. Hang on. Could it possibly be... Could I have anything else? So I guess I would go to chain IK, and then here's the 2 options. There's spline IK. Aligning bones along a path. I'm not calculating a path. Okay. Alright, so I think what I probably should say is that I know for a fact we're going to be working on iterate IK3D. So I'm going to say this is a problem. In fact, I'm going to say it's such a problem that I have a strong expectation that the IK is an iterate IK3D. It really should be. And I'm going to change the name of this too. I think it probably should be changed. I should just call it iterate IK, in fact. So I have to write underscores all the time. It's shorter and it's less annoying. And this should be an exception. What are the kind of errors? Attachment for something. Attachment. Target name. Yeah, I guess I say this. I'll just copy one of these errors. Not enough space. Attachment. Attachment for bone ID. Does not have a setting. Unable to calculate a bone length. Do I need to know bone? Well, part of what I'm doing here is I'm trying to make sure that the motor would not be causing more than a meter per second of displacement. I guess if I actually know the... No, I would not. The inverse... Or the inertia just tells me like how much force I need to like relatively move an amount of mass. It doesn't tell me how far I actually end up moving it. Because I guess there's kind of no difference between like a small, very dense object and a very long, light, or less massive object. They would just appear to have like the same inertia. Which is needed for... motor velocity limits. I'll say displacement limits. Do I need a... Ooh, I can just search on here now. Displacement. Okay, I spelled it right. And I'll just let it go without it. And then length is just whatever the default was set to. Using a default length of that. Okay, and then crawler character, I need to make sure that this should be an iterate IK. It is. Guess I should hit run to make sure there's... Cool. I have so many docs open. Just close them. I'm actually curious. What do I? Wait, 1.8. Okay. I guess I should put a to do here so I know that this is not done. To do linear and actually I think it's just like linear displacement needed for bones attached. Maybe I shouldn't even use the offset. Maybe I should just actually teleport the leg. I don't know if that would be fine. Or maybe I could make it like a half. Honestly, I don't really get how like a single... Oh. Maybe I do get why. Basically what I do here is I say this one should have a linear displacement of like a centimeter, or like 2 centimeters. So I set that as a 2 centimeter displacement, and it tries to do it, but every time it runs, it has to pull back a lot because basically it's being worked against on both sides. So there's like 2 kilograms on this side that are moving, and then there's the main body, which is just kind of not moving at all. So that's probably why. I want to know what this number is. Right, okay. Maybe I do have to have a motor there, because otherwise it's going to be too difficult. It's going to be hard to move this. And maybe I could limit the offset to only be what am I trying to say? I guess what I could do is I could calculate the offset and set the linear limit to be half of that offset. So what it would end up doing is sort of no, it would not progressively move towards it. Oh, well, maybe it would. So in one tick it says we're 1 centimeter away, so let's make that a half centimeter. And then it says we're half centimeter away, let's make that a quarter of a centimeter. I guess that would actually probably work. But I need to comment both these lines out. Linear displacement needed for bones attached to other moving bones. This attempt. Does position constraints... What? Okay, weird. For point constraint, it should all be here. Or not. Point constraint part. So solve position constraint. Okay, it does use the effective mass. That's good. Okay. Which means that basically the large body, if there's a displacement of a meter, the large body would move the large body would move like 10 times or I guess the effective mass becomes like 0.9 something. So it would be that divided by 10. 0.9 over 10. So I guess it, am I just that dumb? Maybe. I just can't think of what that is. If there's a meter displacement, the large body would move 9 centimeters. And then the small body would move 90 centimeters. But I mean, I wasn't exact because there's all these repeating 9s which kind of overlap each other, so the whole thing would be like 0.999 repeating. But then everything else has a point displacement, which basically means the next joint down the line will try to move it back some amount, and the next joint will move that one back, and then they all end up kind of moving back a little bit. Although I think stepping that 16 times is probably enough to like make sure everything is close. But I mean, it's obviously not enough. And I still don't really get why. I may just have a mistake in my calculations up here. Because it seems like once the displacement becomes... once the displacement becomes more than a centimeter, it's almost guaranteed at that point that it's actually going to be displaced by 2 centimeters. So there might just be a miscalculation here. Miscalculation here. I did realize that the error rotation has to be applied in the negative, but I think I tried that and they definitely just fell apart even faster. So maybe just be that up here there needs to be a negative instead. I don't know. Okay, well, that's a good comment. So I know I'm not done with that. Data length, and I have an error. I move the skeleton to an export, so I'm not having to write that. I have if engine editors. If engine is editor hint, I stop. I set up ground targets, so just providing information of that. I think I probably want to leave the friction off for now because that doesn't actually solve I mean, actually, does it kind of solve it? Let me see. I think it still falls over. I think it still very much just falls over. Because it can't... Can we push you? Okay, well, I broke the leg instantly. It's kind of wild. So it seems like it actually just kind of stops it from moving in the first place. So yeah, I need to turn that back off. Back to 0. Because I literally cannot move it. It refuses to move. All right. I will delete that line, but I'm going to add it back and just not commit that line. Right, I need to set the debug back. And then you make sure I close that before I hit save. And then I think I've looked at all that. This was good. Just make sure the only change here is adding that line. Okay, good. We're going to call our leg motors. Something to match the IK, and IK solves from I guess it doesn't actually solve from the current leg positions, does it? Maybe I should do that. Well, no, I think if no. Yeah, I think all I do is I just copy the joint rotations, the relative angle between the joints, and that's all I do. Now I can't help but think about the that Star Wars game where they mentioned that they had to crank their motors up to like 64 ticks, 64 positions, 64 velocity steps. Is this the reason why? Because they didn't think ahead about what changing a motor to match one joint would cause an inverse effect on the two other motors. So they basically relied on that first iteration to just update that, and the next iteration would say, I guess just a bunch of position solutions, really, is all that would be. Or I guess the motor would go in there and read that there's a difference in their velocity. And so the motor would have a target velocity of like 0 or something. Or maybe like a target angle or whatever, and it would know that it's not at that, and then it would apply forces to completely correct for that. And then that would actually mess up all the other motors that didn't want to move. Honestly, I think they just had some other problems. I think they just set their stiffness values to like something insane so that they required that many steps. And then they also probably didn't have this they didn't consider the fact that changing the angle on one would actually affect the angle on another joint. And they didn't think ahead to calculate for that properly. Or like do like a simple iteration ahead of time to try and solve for that. Because I guess the idea here is that since I know which way I'm going and which exact motor I'm messing with, I should be able to like very quickly solve and say, hey, a motor down the chain has actually incurred this penalty onto you, so you need to correct for that now too. So instead of saying this motor should be at this velocity and this motor should be at 0, it's like this motor should be at this velocity and this motor should be at this negative velocity. And the iteration is just going to try and make them match each other. Or match what they want to be. Instead of saying this one should be at like 10, this should be at 0, and this one ends up at 10, and this one ends up at 5. And this one has to say, all right, well, we need to do the negative now. This one ends up at like 15 or like 13. And then it has to go back to 10, and this one goes back up. That kind of thing. Or maybe it was even this realization that the stabilization factor should probably be scaled depending on these. So it was like they were getting diminishing returns, so they're like 32, they still like a 0.2 here, kind of thing. And they just had to keep going higher and higher because the stabilization factor was just too much. It was overcorrecting way too much. I still wonder how that value is determined. Why 0.2 for 10 velocity steps? So it's from the current real, like, current real joint angles. Also, I think there's something else with this that I haven't thought of. When a leg is actually removed from the ground, there needs to be... I don't have any system to handle that, actually. I just assume that if I think the leg should stay on the ground, then it will stay on the ground. Because when a leg lifts up, then it's like... yeah, it still says like, oh, we're not stepping or something. There's no correction, I think. Or it's like other groups are... I don't know. Probably what I mean to do is to use purely just grounding behavior. Is the leg on the ground? Is it not on the ground? That kind of thing. And then probably just use that stepping boolean to check for synchronization of a step. And that's it. Or maybe not even that. Maybe I still don't do that. Maybe I just assume that if a leg is off the ground, I can take my leg off the ground if I want to go off the ground. And treat that as like trying to take a step forward to move the leg. Yeah, I think I might need to revisit that. Cannot balance after small movements and completely unable to match IK goals in a reasonable time. I think it may also be that my IK target should be updated based on where the leg actually is and not where it thinks the IK, or not where the IK is. That's probably the problem. I think that might be also a reason why the legs just sometimes seem to randomly lift, because the IK is trying to stick. The target is trying to stick to where the IK joint is at. Or maybe not even that. Maybe it's trying to like... maybe there's just some weird connection there where it's trying to... In its attempt to maintain the IK to where it is, it's actually just mixing up where the leg really is and where it wants it to be, or where the IK says it should be. So it ends up translating targets off to like places they just shouldn't be going. It's a bit of velocity displacement calculation and like behavior. Because yeah, I think what's going on is that I think that's probably exactly what it is. The leg targets are updating after IK runs, which means it thinks that the skeleton is in a place that it's not actually located at. Yeah, I think that's I think what that means is I need to move this back. I thought this was right. I think it's probably not right anymore. The leg transforms are where the physical skeleton says they're at, not where the IK says they're at, which is what this is doing right there. So this probably needs to be connected to modifier complete, or modifier whatever it is, on physical skeleton instead of this. Because this is where the legs really are. That's probably the mistake. Well, it is a mistake, but that might be the mistake causing this. The biggest mistake. Okay. All right. Okay, so where should I start? I think I might want to start with all right, I'm just gonna delete this line actually. I don't really want to keep that. Let me use my to-do list. Because there's a lot of things, I guess I just can't think of like which one I should start with. Because they're all building on each other. It's not really future to-dos. Fixed rotation effects on lower delta times, I don't even know. I'm gonna delete this one because I'm not sure what that is anymore. I still need to do this, probably. This one's actually testing, it's connecting. This should be... That's a future to do. I'm gonna say add general air drag to all rigid bodies. Okay. So I still need to do this. Technically destruction time is done. Alright, I'm actually gonna clean this up. Should I specifically remember any of these? Because it's always a good thing to remember bugs. Fix weird pitch things where it tries to have a high pitch when the final pitch should be close to 0. There's always a thing with that, where remembering how you solved a certain bug basically means that if it happens to appear again, then you know how to fix it. Why do these have weird tabs? Okay, it was just a visual glitch, I guess. I'll keep those. Okay. So here's things that I need to do. I need to Um, change leg step behavior to be we'll see an internal state and act when unexpectedly removed from the ground. Legs should probably step based on the ground state of other legs and not check. Yeah. Legs should not to any step parameters of other legs. Only the grounding state. Only the ground and comfort state. I think it also means there's kind of a need for a leg to probably track if any of its step neighbors are uncomfortable. So that basically kind of what a lot of it's doing right now is trying to be way too strict about how the legs move by doing a whole lot of checks and keeping timers and multiple Boolean flags. It probably should really just be like the leg asks another leg, hey, are you fine if I take a step right now? And it should say yes or no. That's probably exactly how it should behave, really. It should probably just be like a function call. And then the function contains logic that might be cache related. It might be, say, check my neighbors. If any of my neighbors are lifted, then I should probably say no. That kind of, or if any of my neighbors that I step with are not on the ground, I should say no. Because maybe I want to step soon, or it checks and sees if any of his neighbors are really uncomfortable. Then it says, no, you shouldn't step because I need to step soon because the legs that I care about need to step, right? So it should probably be something more like that. And the idea is hopefully it doesn't stretch so far as to say if two legs are... I guess the idea is if I were to have one leg randomly lifted, or I guess in this case it'd be like a leg is broken, right? That's kind of the same idea. Every time we would ask a question, then that leg would say, I'm not on the ground right now, and that would affect It should basically affect how the hole crawler walks immediately, but not to the extent of like preventing it from moving completely. So maybe that leg would say, hey, I am like destroyed. I'm a destroyed leg. So for me, it's like, this is what my answer would say. That's even what they say too. When I do the ask, I'm not checking this boolean, this boolean, this boolean. I'm checking. Yeah, I mean, it should really just be simply asking the question. Asking, what should it say? It should probably ask its immediate neighbors and then its cross neighbors. Which I guess is probably just all of its neighbors, but I guess there's like indexing that determines that. So yeah, it should ask those guys and say, hey, if I were to lift off the ground, are you fine with that? If a leg is destroyed, it says, I don't really have a choice in the matter, so sure, why not? If a leg that, if there's a leg that's currently not destroyed but in the air, it says, no, you should wait. Like you should not lift off the ground right now. Because I'm either taking a step, and I know I'm taking a step, or one of my neighbors is really uncomfortable that you may not be checking. That kind of thing. Basically, the idea is like, I'm waiting on one of my neighbors to take a step right now, so you're not allowed to take a step. That kind of thing. Okay. There's that. Make legs act on the physical locations, not the IK state. By running up and down leg chains. There might also be the question of when I destroy a leg, how should I treat the IK? If the leg is still partially attached, I guess the idea there is you probably want the balance, which means, I think at least in this case, generally, that leg basically becomes like an idea for like a shifting of the center of mass. So if the leg like pulls up or pulls down, if the leg pulls up, it'll shift the mass. It'll bring in the center of mass and move it up a little bit. If it were to go down, it would do the same thing, bring in the center of mass, but lower it a little bit. If it were to extend out straight, it would pull the center of mass in the direction of that leg. So it could be used to, I guess, just maybe the idea there is you would lower the center of mass. Does that make... Yeah, lowering the center of mass makes things more stable, right? So somehow I might need to go in there and change the IK so that... Or change like a bone length or something. So if the leg is destroyed, I set the length of that bone to probably just be 0. And then change the IK so that either we disregard that joint or change the end node to be that destroyed one, just to, I guess, reduce what IK, how much IK processing is happening. And then probably just change it so the IK target just snaps to the center. Or snaps to some... I mean, I guess in this case I can just say the IK. If any piece of the leg is destroyed, the IK should probably just try to... I mean, what would it do? Well, I guess the real question is, what would the actual creator of that decide? I guess in my mind, the creator would not even expect the robot to be missing a leg. So then in this case, it's more like a hack, right? Part of that hack is that they want to keep the robot attacking you even if it's missing a leg, because that's a pretty obvious expectation. So maybe the hack would just be to I don't know, unlock the motors. Maybe not unlock the motors, but make it so they're just using like friction to keep themselves at 0 velocity. And wherever they end up is where they end up. So motion can still like move the joints a little bit, but they're just basically acting on friction. That kind of thing. Yeah, I think probably just a good analog is to set the angular the target velocities of the motors to 0, and probably lower the maximum force to something that would just be like a friction force, so maybe like 10, 20 newtons, and just let the motors do that. And then yeah, probably just turn off IK for the whole thing. So what would that mean? What would that look like? Is that as simple as going in here and clicking enabled? Huh. How about I turn it off? I mean, honestly, maybe what I need there is just to add, maybe I actually need to that might actually be a compile thing. Odd iterations run up or run from end to root. Even iterations run root to end. Errors determine velocities, and velocities incur proportional errors on the next higher and lower joints. Test 1, 2. Oh, and then I guess this would also be experiment with a Is that? It should be called that, right? Yeah. Because I think a large benefit to this is that I know these are all essentially two bodies at a time. The reason why a lower factor works in the general case is that everybody's kind of moving independently of each other. So when I add an error to myself, that does not become an error on the next one, but then it calculates that it has some of its own error, and then it has to correct for that, which adds back to the other one. In this case, I know that when I add, I know exactly how much error is passed on to the next one because it's just a two-body thing. I know exactly which joint it applies to, or just two other joints on both sides. And I can basically do 100%. I think I probably can just do 100%, then it's perfect. And anything less just means I get a less accurate result. It doesn't actually improve how it converges. It just means that it would mean more iterations to converge, is my expectation. Or it may even be that I have to do like a third at a time. And any higher than that, and it's just like incredibly unstable. That's also possible. All right. And then I have the positional constraints. So okay, so here's all the ideas. Is there any more? Do I need to have... I saw the general case where the body drifts and it never is able to stabilize. I think there's two solutions to this. I think I probably should use... I don't really want to. But a solution would be to have just a spring body at the end of the leg, which can act as the... I guess not only as a... some sort of like a grip mechanism where it can help try to keep it in place or like apply... actually, hang on, what do I have here? There's a lot of stuff here. Hang on, what? Okay. I immediately forgot what I was gonna say. What was I gonna write? The reason I kind of don't want it is because this would act as like anti-gravity all on its own. Because if it was like a spring that's allowed to pull, well, I mean, I guess on the other side, it means that well, here's the thing. I know that my calculations here are probably simpler because I know there's a simplification I can make, which is just compressing everything to be in line with the body plane. I know that. But if I were to add my own spring, then this means they're starting to do the same thing. They're starting to do the same job. Which maybe is fine, because I guess maybe what that means is in the middle ground of collisions where my code can't do anything, there's that little bit of extra help, I guess, that I get. And why would I need it? Why would I need it? I would need it because I think I do... Okay, well, it's more like this. It would not be able to pull in some sense. Because if I were to just set another rigid body, like a small rigid body at the end, and then have this one, and that whole system acts as a spring. Okay, here's a big downside of that. It makes the simulation more complicated, and it means that this is going to be less accurate if I do that. Because now I'm adding a whole new spring to the entire system. If I were to instead have my own system, then I just say whatever I'm colliding with, that becomes like the... I can have my own grip force. Because I just raycast it out and I say, all right, I'm hitting this thing and I should be gripped to it, so let's pull our body into it and pull it closer to me, that kind of thing. But I guess it also means it requires tweaking to figure out like how far out does that apply. Technically, the collider should probably be like a cylinder rotated flat, so it slides out this way at an angle, or it matches the leg angle, but it's oriented to match the ground normal as well. Yeah, so I'd actually have to rotate that shape depending on the surface. But then I don't really get rigid body friction from that. I have to do friction myself, which okay, that is part of it. Friction needs to be solved. Friction needs to be solved after legs update ground state and applied locally to the main body. Also need to yeah, I think maybe, I don't know, should I do this? I can essentially convert those ground casts that each leg does into a spring cast. Which the intention behind that is it should allow it to apply pulling forces back into surfaces if it starts to detach. So instead of just like slowly pulling away from the surface and then not ever pulling back in, it should like be pulled away and say, no, I'm actually grounded and I want to be closer, so we'll pull it back. I saw you, dog. Yeah, I did. Okay, it's probably just getting close to lunchtime for me. Anything else? Yeah, I think I'm gonna consider using spring for maintaining and softening, for maintaining ground contact and softening impacts on the legs. Right now, legs just, you know, I think it's actually, I think I really need it actually. Use spring cast and prime pivot for maintaining ground contact and softening impacts on the legs. When I have legs just hover above the ground or rigidly collide and push the entire body. Yeah, this solves a disconnect between where the and then I can even say like also allow disabling grip like because what I also see, good boy, what I also see is that like the IK target is like 5 centimeters away from where the leg is, and because of that disconnect, it's like constantly pushing itself away, or it's never even getting close to it. Which I guess is actually probably a problem up here as well, if the IK targets are updated to be where the physical node is, and then it will move from there. So I might get to this one and realize I don't need it, but I think I actually do need it because of this. That kind of thing. Okay. I'm gonna go grab food. I'll be back. I didn't unmute yet. I'm back. I've noticed the crawler has left a leg here. And where it's sitting right now. Yeah. So I think that what would happen here is that, or the reason why this is pushing back is because of this leg basically almost entirely, or actually it's coming back forward now. Is because these legs are trying to extend to match their angles. But in doing so, they end up pushing into the ground and shifting the body. All right. But I've got food, and I'm going to eat. I don't think, now that I'm thinking about it, I think there's a problem been like in my face this whole time. Is that its velocity vector doesn't really make sense, even to begin with. It seems like it's not accurate to what's really happening. Because as far as I'm aware, a single block of the thick lines here is 1 meter. And it seems like it's moving way slower than that. Generally. Like it's sitting at like 0.3 centimeters per second, and if it was, or 0.03 meters per second, which was just 3 centimeters per second. And if it was actually moving like that, it should be covering like that full block, and at least it should be covering obvious distance. And I think it wasn't. It looked like it was just totally static, but constantly moving up at like some velocity that just wasn't correct, right? So either my debug is wrong or something else is wrong. I don't really know what. Well, that's how it lost a leg. Like, Human is generally stable. Moving at 10 centimeters per second almost straight up. That's not what it's doing. It's just not moving that way at all. Or at least it doesn't feel to me like it's actually moving that way. All right. I will be back. I'm going to take the rest of my break outside. That's my plan. We'll leave this here. I'm pretty sure it's going to end up wandering off into the distance in that way because that's what it did last time. So I'm going to anticipate that and just sit here. I'm back. This leg is still wirelessly connected. The joint is rotating. Okay. Whoa. Whoops. People are tired of waiting for the Bungie layoff news. Went and checked the mobile Destiny version. Crashed 97% in revenue from peak. Bungie's just run by an idiot. So. What is it? It should be disabled for the entire chain. And motors set to 0 target velocity with low force limit to simulate disabled motors that only have friction. Oh, and then I think I need to do this too. Copy angular limitations to joints from the IK settings. All right, so I think I should probably actually start with the first step, because I think this is gonna immediately put it into a better state overall, which is connecting it to physical skeleton modification process. And then hopefully it's not totally busted at this point. It should just, I think it should just be slightly more stable. And in fact, it's kind of looking like it is. Although it's definitely falling over right now, I think. Yeah, that's not... Oh. Is that okay? Is that leg allowed to bend that way? I think it's not. No, actually, that's probably fine. But it basically, yeah, okay. I just want to see if it stands back up. I'm actually really curious about this. Can it stand back up? It might actually be a big twist. I bet if I allowed the leg motors to run a little bit faster, it might be okay. Oh, okay, it just twisted one of his legs off. Well, alright. Alright, so what if I allow legs to move a little bit faster? Also, the velocity is just the rotation that it has to go to now. Yeah, this is definitely not falling down 5 centimeters per second. I just don't believe it. It does seem like it's more steady, which is actually really good. It really does seem like it's more steady. It's not like accelerating in one way. It's like it gets some velocity in one way and then it, I mean, I think it's trying to like move its legs right now, so it's really unstable, but it's definitely a lot more stable. And I think part of that is because of where it thinks the legs are at this point. It's able to do better balancing. What the hell? Okay, just all right. It's better able to balance, I think. Yeah, what if I just did velocities? Yeah, no stabilization there at all. Okay, but I think that step's kind of it, right? But I do need to verify. I guess just look over crawl the legs and see what they're doing. Because I don't remember what they're doing. So we read in the current ground leg transform as being wherever the ground bone is. Target bone position is there. Ground cast, force update transform, force shape gas transform. Okay. I definitely can't do that. What about just doubled it? It does seem like the IK is snapping sometimes, and I'm not really sure why that happens. There's probably a good reason for that, though. A good reason why it's happening. So we do this. Re-update will run all of this stuff, which is depending on target positions, target bone position, ground cast, or ground leg transform. Yeah, target bone position, move towards target position, right? Oh no, there's two things happening here. This actually has a certain expectation. The expectation being that pre-update runs after leg IK. Let me turn on preview for the IK targets, I guess. And then I guess the step target as well. It just can't reach this target. I'm not sure what the snapping is. There's definitely some kind of snapping happening. Or sometimes that IK target just teleports somewhere. Which is really not good. I also wonder why the leg is where the IK should be, and the IK isn't matching the current layout of the leg. It's like off by a lot. It seems like it's off by too much. Did I make a change? It could be the rest correction angle. I'm correcting for a degree every time. That could be too much of a problem. It needs to be on, but maybe a degree is too much. It may also just be that since I'm done... Yeah, okay, I think this is the next step. I think I just turn that one and I kind of leave it on. The legs should be good. I think the next step is that I need to apply the limits that exist here back onto the motors. Because I think what's happening is the motors are kind of allowed to go to a position that maybe they shouldn't be in. It just happens to be that way because maybe they get pushed into that position. And then the IK is like, at that point, sort of snapping because the motors are beyond its IK limit. So it suddenly thinks that it has a huge rotation to come back to correct. When in reality, that should be part of the iterative process that the motor is beyond its limit and it's like pushing back very strongly to try to return to that limit. It needs to do that. It should not just rely on like a simple motor. It should rely on like a very rigid constraint. I think I fixed it. Yeah. It's just some random line changes. I'm just gonna delete this because I don't need to see it. I'm not checking to see when something breaks anymore. Let's set this back to 0.5 because it's not even used right now. Well, hang on. Two things. There actually is a disconnect here. The target bone position is not this. The target bone position is post IK. This is happening, I think, before IK. Yeah, update ground leg transform. So okay, so this is just definitely wrong. This should definitely be post IK. So I'm just going to leave this called that and just pull this out into a different call. This should just be a different call. Because it might be why it's moving so slowly is because it's not checking the IK. Wait, this is update like transforms. Oh, right, yeah. I kind of want to inline this, but also I shouldn't. I'm actually going to inline it. Then okay. I mean, they should be functions, but I don't know. It's just a bit annoying. It looks annoying both ways. Is there anything that's like for each? Whatever. I'm just gonna deal with the fact that I think it looks stupid. Okay. Now what? Like, so definitely moving faster, but also there's still problems, right? And I'm kind of curious, do I just have like some insane leg lift height that I put on here and left forever? Because I don't know why AK is trying to... I don't know why the target is moving it so high off the ground. Okay, well, regardless of what I think might fix it right now, do I know that this is what it should be? The ground leg transform is definitely dependent on where that is physically, and then target leg transform is dependent on where the leg, the IK solution is placing it. And do I have it in the right order too? Physical leg, yep. Maybe it's not this. I don't know. I think it's not right. I think it actually should stay before IK. Because this is saying, all right, where are we now? This is where we should be, kind of thing. So was I wrong about this? Should it be still here? Let me see what comfort distance is. Oh, that's nothing. This will tell me. Target's position rest delta. Target global rest. Thou. What? Target global rest is local rest. Target rest position. So I know I'm comfortable depending on where my target position is. After updating target position. Okay, I feel like I'm convinced. It should just be this. And then I'm going to add this function back. I'm just going to change the name to be that. Metaphysical skeleton, that one's just called that now. And then this is called that now. And then I have an extra line beneath it. Or an extra line above pre-update. Did I? Oh yeah, it only matters if I change the default and then hit save. Why is that motor in the back just rotating like this? Yeah, whatever. Yeah, I take IK targets should be stuck to the blue one, but they should be only slightly far away from where the light currently is. Right? I mean, not snapped to the blue one. They should be snapped to the red one, but only slightly further away from where the red one should be. And I'm not really sure how that is rotating that way. It should just not be allowed to rotate like that. Are these like loose on Y or something? What's up with that? I don't know. Okay, but do I know that this is correct? Am I sure that it's correct? I'm renaming that method and then deleting this. Yeah, okay. Need to get debug back. Well, I can just add iteratively. And then I will update to-dos. Well, not quite yet. This should be that one marked off. I'll leave it unmarked. Actually, let me only send the to-do changes. Okay. Oh, and then should do that. Yeah. Um, yeah. Oh, and then now I really want to say, ideally the physical system should only add um much effect on speed or should have much effect on movement ability. That'd be an ideal world. It would behave exactly like it looked in IK, it's just that now it has the legs can wiggle when you push them and break off. That's a really big one that I need. All right. So the Boolean should go up here. I guess probably right above physical skeleton. That's like enable or disable. Let me make this a group. Should legs needed for jump be in the legs parameters? I mean, it should, right? I'm gonna put it all the way down here. And then I want a group for this. So physical skeleton, then I want to have property hint group enable. Checkbox only. True by default. Okay. And my theory is that eventually I'm going to have probably some parameters for leg eye case specifically. Physical skeleton might include, like, you know, how much before we break, right? That kind of thing. Leg IK might be, I don't know, something. But I'll just go and break it up. I probably have to open this and save it to fix. Okay. So what I need to do is, if the physical skeleton is... Also, this returns up here at the top. If engine is edited, hint return. So probably should just be turned on. If we're enabled, and then if we're disabled, if we're disabled, it should be connected to that. Physical skeleton just shouldn't run. What? Oh, there's so many methods. I don't understand. I thought active. Oh, yeah, active. Active false. So now it won't be processing. Yeah, in fact, I'm actually going to turn them off. I'm going to leave these off by default. Enable it, set those. And then if it's disabled, I also want to say, yeah, there's all this stuff that happens here that needs to run differently. It's more like when I initialize them. I don't think it matters when I initialize them, as long as I do it in here. Well, I think it does matter. I have to do it after all this stuff, but... The ground targets, right? So... If we're enabled... The ground target should be that final rigid body. If we are disabled, the target should just be that attachment. Okay. So that should, I feel like that should be it. Well, there's ground targets. I guess now there's target bones, which is doing what? It's just setting the target node to the end bone. Yeah, okay. That's fine. Yeah, so both these should be off inactive by default. Which is weird that it's saying that's what the default is. I kind of don't understand why it doesn't say that one here. Whatever. But then here, this should be on by default, and then out here, I will turn it off. Well, yeah, I guess I'll just try both ways. Still not quite yet. When that's off, I need to totally prevent the skeleton from even running at all, which means it should be inactive. So do I need to read it up here? If we're not initialized, then I want to say if we are active. Actually, more. I guess it would be if we're not initialized and active. So basically, until we do that, we're not going to process anything. I mean, but part of it is that it runs through the set of body joints. I don't know. I guess I could try to make it run live. What it requires is me to go through all these joints and basically disable them. But not only that, I want to make it visually. I want to hide them visually at the same time. So I guess that's what I could do. I can just like set visibility to be false on the rigid body. And then just set them to be disabled. Okay, I'll do that. And I guess I'll do like, yeah, if we're initialized, we always need to, if we're not initialized, we need to initialize. And then I think maybe this can be a combination here, where if we don't have bodies, check if we are active, I guess. I don't know. What does has bodies mean? I guess has bodies basically means that we have things that we want to run through. So I guess what I should say then is, yeah, I guess I'll do this. If we are active and I'll just write it out. Making that that's like activate bodies. Whoops. And then, yes, this is where I want to do this. Whoops. Otherwise, we are not active. And I want to know if we are not active but we have bodies, and I want to deactivate bodies in return. I guess this would just be an else. If we have bodies, deactivate bodies and then return. And then I guess just ultimately at the end, we also need to check this. If we are active and we don't have bodies, we're going to run activate bodies. If we're active and we do, then we're just going to ignore it, but then we check it again anyway. So yeah, it's probably like I want to put this up here, so I'm not double checking it every time. I'm only checking it when I definitely know I need to. Actually, no. I want to make it a different value. If we are active and not bodies active, run that. Otherwise, if body's active, deactivate and then return. So just kind of run through this twice, right? And when it's turned off, it'll go to here, it'll say we're not, and then it says we don't have active bodies, and we just return. So we're just here to ensure that they get deactivated. Okay. So then and part of it is that if it breaks off and I flip from IK to non-IK, I'm not actually going to fix the body, I think. I'm just going to leave it destroyed. Because part of destroying it is deleting it, so I can't really remake it. Plus, if I did, there's the the risk that I put the body back into place and it's like through the ground and then it stays stuck in the ground. And it was just kind of useless in the first place. So yeah. Deactivate bodies. I think I want to make sure that when these are set up, so I load them in. And when these are set up, I think what I want to do is I want to make sure everything is turned off. Well, actually, it's literally just going to be these three. So, yeah, update all joint paths. I'm not copying process mode. It's either going to be disabled or inherit. Copy velocity. So this is going to go into... Yeah, this is going to go into like the activate thing. But they will be disabled by default. So actually, before I even do that, I'm just going to copy this. And then I think it is just going to be as simple as going through every joint, right? Yeah. I have to teleport them to match the bones. That is actually a real problem. They need to match the bones. So do I have to save the actual attachment that they were connected to? Attachments. Make joint data from bone target. So yeah, it's literally like part of it. So I think what I'm going to do is I'm just going to make it so that these remember their targets. And then these will teleport back to them when they get loaded. So many things I'm saving. So many things I'm saving. It's not a bone target, is it? Actually, I think it is, because I think modifier bone target is the only one that has a name like that. So yeah. So it'll save the attachment. Local position as state, transform, states under mass, and then minus main body state, which is just going to be this. We're only teleporting the body. So body global transform will be equal to attachment global transform. Teleport to join attachment node. Copy velocity. Which I need this for the center of mass. So I'm not going to copy the state transform origin here. I'm going to copy joint data body transform origin. Strike global position. Help joint attachment node, copy processing state to bodies and joints. Actually, I should not be doing parent. I don't know why I'm doing parent. That's just stupid. Don't do parent. Just the body and the joint. So that's activate, and then deactivate. Oh, and then make body visible. Deactivate will just kind of be undoing, not really undoing a lot of this, but undoing some of it. Just setting these two disabled. And that's all I really gotta do. Hide it, disable it. And down here, that gets deleted, and these all, I don't do parent. I think I should want to run this up here. Okay. Initially disable joints. Good. So they'll be deactivated, we hide the body, we set them disabled. And then when we activate, we set them visible, we copy the process mode from the main body. We teleport to its attachment transform. Which I wonder if I need to tell it. Notification transform changed. But I think this does it anyway. I think doing that does it anyway. I know there's a case where this isn't set. Just gotta index everything. Notification transform changed. So I'm guessing looking for that. And I'm looking for collision object. Body set state. Good. Okay. Get global transform. Cool. So I at least know that this notification has to be called, but my thinking is that setting the global transform calls this already. Set global transform. Oh. It just updates its transform by inversing. Okay, so I definitely do have to call force update transform for this to work. And then the notification propagates down. I don't think I need to do this because the joints should always be attached to the body. So it should be relative to the body. So as long as the teleport is correct. Oh. I noticed something here. Okay, this is probably where having like a general method of iterating through the joint chain is preferable, because what I should be doing is I should be going joint attached to the main body and then all the joints following that in that order. That would allow, because what happens here is that I don't think this really triggers the joint movement like that, but it might. I guess I just see. I'm going to be looking for files. Yeah, it only does a joint update when something changes. It doesn't do that for transform changes. So I really shouldn't have to do this. I really should not have to do this. Yeah, okay. All right. We initially deactivate the body so they're not visible. and I have it turned off. Okay, so I expect to see that IK is going to be how it runs. Okay, so the legs are still running, which is just confusing to me because they shouldn't be. They should not be running. Okay. So why are they enabled? Why weren't they moved out? They're not, they didn't get moved. Why did they not get moved? It doesn't even run this if it's not active. Okay. Which is actually stupid because I happen to know for a fact that it does run when it's not active. So I don't understand what that's about. Because the leg IK I have deactivated and it still runs, which is why I kept getting bugs or errors printing. Because it was activating before it was even supposed to run. Unless up here. No, it is definitely meant to be running even when it's supposed to get that initial update. Okay, maybe what I do is I just do this. I just run physical skeleton initialize setup body joints. Because it definitely needs to run. This definitely needs to run. Yeah. Right. Invalid access to setting count on base object of type nil. Okay. Yeah, you know what? Let me just whoops. I don't know. I'll figure out live updating that later, I guess. But for now, it's just gonna be like this. All right. So I want them to operate the same when they're turned on or off. So when this is off, desired friction will just be 1 until I figure out how to make it work. It's totally bust. In fact, that actually doesn't even work at all. Also, yeah, it looks like they're just kind of completely broken. They don't really, the legs are not walking right now. Interesting. It also doesn't rotate. What could that be? Very strange. Why? Okay, yeah. Interesting. I keep forgetting Michael Bay is making a Skibbity Toy movie. That's not true. It's just not. That can't be true. Google it right now. I don't wanna. I don't wanna. Okay. What is this, April Fools? Michael Bay is not directing the Skibbity. What? What's funny is I just got two different I just got two different responses. I looked at it on my other one and it said it's being made. And then there was this. And then I searched here and now it says it's not. What's going on? This is also 2 years ago. Despite earlier denials. Dude, I don't understand. Why? Okay, the thing is, he's saying, guys, I'm not making it. And everyone's like, no, we promise he's making it. What? Why would he lie about that? I don't know why he would lie about it. This is a dream. Right. Okay, so at some point the legs broke and the legs don't work anymore. Why? Why? Leg IK modification process connect update leg transforms. Let me enable. And I should see it doing normal stuff. Center of mass on a null. What? Huh? I don't believe you. Try again. Damn it. Wake up. Yeah. Why would it not? Oh. Wait, I do get it. So the way that this works is disable mode, remove. Make static, keep active, right? Okay, so what's happening here is I set it to be disabled. Disable mode removes it from the simulation. So I need to know exactly what that means. It's on collision object. Notification disabled. Notification enabled. Apply disabled. Apply disabled. Did I just say apply disabled twice? I did. Apply disabled. Disable mode remove. If inside tree, get singleton body set space. Okay, so it moves it to another space, which just has nothing going on. Apply enabled moves it back into the space and says space changed. What does that do? It's only implemented. Oh, update joint constraints? Oh. Update joint constraints. No. Okay. I do have to... Damn. Well, I mean, actually, here's the thing. If I move everything into space, and then I were to do a deferred call... Oh, also activate bodies as setting a Boolean. Bodies active. So bodies active is false by default. When this runs, I need to say bodies active false. And then what I really need to do here is I need to say a deferred call. I can still teleport them, update the transforms, that's all fine. Or no, I can't. Oh, now I'm really confused. Process mode changes, but it doesn't yet have a body state. Can I just get the center of mass? Oh, I'm looking at the... Return center of mass. I mean, I guess it just has to happen. No, it really is. This really is a problem here. I need to know its center of mass. But it has to exist in a space for like 1 tick before I can know that. Which is a problem. Also, when I enable it, it's gonna... I mean, it's fine. It's actually just fine. Well, I guess the thing is I actually know the center of mass when it loads in the first time. Don't I? Saving even more. Can't type it myself. Okay. Save that now. Center of mass exists. Maybe. Maybe. Yes, it is, because I do all the loading, and then after the loading, that's when I would have copied it. Right? Set up body joints. That. Okay. And I don't save it down here. Set up here when I do activate. I don't use that. I use joint data center of mass. So silly. Whoa. Wait, what's happening right now? It's not physically simulating at all. Oh, and then I say body's active equals true. But they still should have been parented like that. Yeah, here we go. Okay. Also, hang on a second. What is this? Yeah, the legs just aren't like completing a step right now. Okay. Well. Turn that off. I hit run. Yeah, so it's definitely a bug right now with walking. What's going on with the debugger? Parent node is busy setting up children. Add child. Reparent. Consider using call deferred. Right. So true. It's so dumb. Okay. All right, well, I guess, I mean, I think this is correct. Obviously, well, I don't know. I feel like what's happening is I must have broken something because I have done quite a few commits, and it's possible that I've just broken how this works. I mean, I can turn all the debug, I guess, and see what it's saying. It might be the ground cast is not working. In that case, it's like my fault. Well, it's obviously always my fault, but yeah, and then they're not dropping. Okay. There's a slight change here. The slight difference is that I might have been doing skeleton updated. What? Okay, I guess it just somehow randomly fell over. I'm not really sure how that happened, but okay. Alright, so that's... didn't make a difference, which is good. It should not have. I'll be right back. I'm back. No, I've lost it. Right. Legs are definitely... I mean, at least I think they're not working. It's hard to know. Wait a second. When I set the IK modifier, connect to update motors. Set IK modifier. Okay, so I can still listen to that, but I think what I need to do then is I need to, instead of update motors, it needs to check if we're active. And if we're not active, we don't do anything. You should not be doing anything. So it'll be a little bit better. I mean, it's not that problem, but... The weird thing is they're able to step, but they aren't. They reach that like up part and they can't come back down for some reason. Why aren't they able to come back down? I'm gonna look to see why, but I think I'm not gonna fix it probably. Because whatever the problem is... Yeah, let me do this. So they should be in a... They should be in a state now where they're still trying to... Where they're trying to come down. So I'm gonna see why they can't do that. Which is running in... It could be anywhere. I say it could be anywhere. It's definitely in... just the general update method. Update step. So let's go here. Do one tick. I'll just step through. This is... I look at the index I'm looking for index 1. So I'll check continue if it's not the right index. Yeah. I'm looking for index 1. Okay. So update step. We'll go in here. I guess I'll check the values. Stepping should be on. Stepping is on. Is moving is off. Is lifting... Why is moving off? I don't think is moving should be off. Is moving. The leg is currently in motion, but this is definitely true. Yeah, this is what I don't get. Why are these... Can't start step, we must not already be moving. Must not be moving or stepping. Is moving is always false. Interesting. But that also doesn't make sense. It is always false. I think I know what is moving is for. I think I remember. Is moving is meant to be a generic thing in the future for the leg is moving, like to go to a position where it's... Yeah, I think I understand it. It doesn't do anything, so that's fine. Is stepping is on, is lifting is on. So it looks like what's happening is it's not able to finish the lift, is my guess. Let's step over that. We are stepping. This is debug. I don't care about debug. Body has desired forward. We update the leg speed. So leg speed becomes 3. We amplify it slightly. 5.4. Step current. So we extract the Y component out of that. Step goal is step target. We zero the Y. Step current, step target. So we do have a distance between them. Step delta is leg speed times delta times current distance over step distance. Okay, I guess it's just to ramp it up to like a higher speed, to double that speed. Okay. Calculate step vector. If 0 leg swing, I might return current move towards that with a delta. Okay. I'll be right back. Back. Okay. Still looking to see what's going on. None of these are 0. Yep. Check the angle? Should be like 0, right? What? Current vector, goal vector. Interesting. If it's a straight line, what the hell is this? What is this? Also, it's signed angle 2, my own custom one. Wait, what? Hang on. Also, how does that even work? Oh, because these are all relative to the body. Right, that's why they work. Check angle. It's not pi. It's not 0. Square root them. So like 16 centimeters away. Some math. New length. From 2, 1, 0, 2, 2, 6 becomes 2, 1, 6. Then rotated. Ah, right. Yeah, I'm like taking that as like a vector and swinging it. Yeah. And I'm doing partial swing. Fixed to delta, rotated step. So the incoming step, I guess, is current. It's my rotated step. So it pulls in on the X and goes forward on the Z, which is what should happen. Right. It's a little bit closer now. I might need to view it from like above. Oh, I better know what this is. Oh, I know I have a max step height. Step target Y plus a smaller value between the height and the current distance. The current distance is 2, 6. If vertical is less than max step height. Interesting. I wonder if lifting is even actually used anywhere. It's just taking Y and moving that Y from this value to that value. So it's trying to raise it up, right? Oh! I remember what I did. I just remembered. I changed I constricted the angles a lot to do testing, and now I see that it's too much. Okay. That would be under, it would be here. I have to go look at the history to see what it used to be. I think some of I've moved around so much that it's lost too. Well, I guess not lost, but the limitations are. Oh wait, maybe it's actually not. Degrees says 60, 70 says 70. Okay, so it's actually not that. Oh, never mind. I thought I had changed that one. That doesn't even matter either. It definitely should have enough room to lift all the legs anyway. Deterministic. That's something I have to turn off. So when this is enabled, deterministic is true, and then here this false. Whoa. Yeah, why does this happen? It's not like it's not accelerating for some reason. Just got hit by that. Okay. All right. I think that's just about it. So when we load like this. I'm gonna do this legs needed for jump as its own commit. Split that. No. Yes. Yes. No. Yes. All right. Okay. And have I already marked this one? This is the add bool. So yeah, I think now what I'm gonna do is I'm gonna actually move friction up here because I need friction to be working right now, because right now it's just not working at all. And then yeah, and then I think there's this as well. I need this to be functional. Without that, but then I know I'm building it for it. But it still needs to work the same in both ways, right? This is also, I mean, it's not really, okay, it is a physical thing. In the sense that I'll be treating the ground as a spring. So I guess kind of what I expect to see is that I'll have to figure it out. But I think I know that the order of these two should be like this now. I need to have the crawler walking normally again as soon as I can. So I'm saving that center of mass so I can do the activate, deactivate stuff. And the attachment for the same reason. The ground targets changing from just being the attachment or the rigid body. Nothing been changed in the legs, so that's good. That's just all debug stuff for me to see it. I think I need to send that. Though I'm not really sure which one that is. And then I'll send test world. Those two moved up. Okay, everything looks good, except for that one. I will not be sending that one. I'm going to leave a note on why deterministic is set here. I'm gonna say it has the effect of just copying the joint position into the working chain state. I'm just gonna give it a bit more from IK. Ensure this is off. For IK mode. See above note. Understand why this might be enabled. Okay. Good, I've got a good note for myself on that. Should I leave a note on why I need to have center of mass? I guess I should, right? That it would be nice to remember. Basically like a bug that I already solved, so I want to be sure I don't recreate the bug kind of thing. Something I mentioned before. Yeah. Good note. I said activating false there. I don't think I need to send test world. Yeah. I'm just not adding crawler leg or seed. Double checking, I don't want any of this. That's true. And I do want all of this. Okay. Yeah, actually thinking back on it, I think I should leave a note about this instead of activate. Probably immediately. So from the root, from root to end. And that's it to do. So yeah, I think the idea is that just probably when I build the joint data, I need to make sure that joint data is the joints array is organized so that it is always root, next one, end. Always in that order. So if I go through it in reverse, and also if I delete nodes in between, I'll still be running through it in the right. Also, if I delete a node, I think I need to be sure that I delete all, not delete joints afterwards, but I guess maybe set some kind of flag on the data that says it's no longer attached to the main body. So that if I'm going in reverse, oh, actually, I don't know. I think maybe what I do is I just say, I probably will delete it from, or not delete it. I'll have like a second list. Or no. I don't know. It needs to be reorganized so that I can iterate through active joints in either order, in either direction that I want to. And also that I still have all of the joints, even the ones that are technically like deleted and no longer running, so that I just know, I just have the bodies, I guess. Which I don't know, maybe I really don't need it. I'll think about it. It probably is actually the case that I just want to delete them. But when I do delete them, then I need to make sure I go through the rest of the joints in that chain and also the same thing where like or I guess if I delete the joint, that's fine, right? The joint deletes, but then the other ones that are still like technically live, I need to go into there and say, set it up to just be like a friction motor, and then probably even do like a scale out. So maybe it maintains its velocity, but it like loses power. So actually, I really don't know what would happen to the motor. Yeah, I think all I do is I set max torque to a low value, I set target velocity to 0, and then I just leave it. And I also drop it from the list, so in iteration, I'm not running over it anymore. And the other part of the organization is I need to know when a chain ends. I guess not really know when a chain ends. Well, yeah, know when a chain ends, honestly. I guess I don't need to, because I'm iterating through all the joints. As long as I'm going through it in the right way, I'm going like chain 1 into root, chain 2 into root, and then when I go back the other way, it's chain 2, root to end, chain 1, root to end, that kind of thing. Yeah, okay. Just a reorganization there. So I think I want to add to the to-do. Probably right around here. Well, I don't know. Do I need it there? I don't think I need it there. But here, stutter. Here I need to have it first. So, to be in chain order. So forward iteration is root to end. Backward iteration is end the root. When a joint is destroyed, should be it and all joints is destroyed, it should be deleted. And child joints should be disabled and removed from iteration list. And parent should be set to non-functional. And target some tucked rotation. I don't know. Target some safe rotation. Something like that, right? Yeah, I'm not adding that one. All right. Okay. What is this doing?
Oh, it's adding the Boolean thing.
Right. Add Boolean. For virtual to physical. Crawler, I don't know. Crawler legs. Probably crawler and switch. I haven't tested it live, and I want to test it live because I know it's not going to work, but I'll fix it when I get there. Because I'm pretty sure I need that chain iteration thing for the joints to work, because when I turn the joints back on, they rebuild, which means they check where the parent is and where the body is, and if the parent hasn't been moved into place yet, then the joint is going to have a really incorrect offset, and then we're going to teleport it, And then the joint's gonna be like, oh, I'm like way too close. I need to be like 10 meters away. And it's just gonna like blow the thing apart. So crawler can switch between pure IK legs and physically reactive legs. Probably not at runtime yet. May cause just explode. It is now clear the it doesn't work anymore in pure IK mode. Needs friction and ground springs next. Also update crawler to-dos. Okay. And I think that's going to be where I stop for today. Yeah. Friction will be next. And then Springcast, and then hopefully by that point I see the crawler. Well, the friction should allow it to start working correctly immediately. It seems like there's a stepping problem too. So maybe I want to look into that before Springcast. I might reorder that around. In fact, I'm going to. I think I'm gonna say that I need to actually get this, because that's obviously wrong right now. The legs are stepping in a really strange way. It might be friction related. I don't know. But if it's not the case, if it's not the case, then I need to make sure that that's fixed before I get into stepping back into trying to make it physical again. But I'll be testing it every time. So once friction is in there, then I will check that there's still good friction even when the legs are turned on. Although it won't really be walking very well, I think. Or at all. Or it might be like way too much friction because the legs are applying virtual friction and then the rigid bodies are applying additional friction on top of that kind of thing. But I mean, I guess at least in that case, oh, wait a second. I need to make sure that if I'm applying friction, I need to apply it to the end of the leg at the same time, because I will be applying it early, right? So I'd have to change the velocity of that leg, change the velocity of, I mean, I guess the technical way to do it is that when the rigid bodies are turned on, I should only be applying impulses onto the rigid body where it's in contact with the ground. Or at least where I say that the ground contact is. Which will incur some rotation. Which, when the physics simulation updates, it should pass that on eventually to the main body. So the main body should stop. Yeah. Applied locally to the main body for rotation. Yeah, I'm going to say friction needs to be solved after legs update ground state and applied locally to the ground leg body in physics mode, or the main body in IK. I don't know, virtual mode? Like, I don't really know how to describe these. Traditional linear acceleration rather than applying friction as a whole to the main body. Hey everyone, I'm actually wrapping it up right now. But I've just added a bunch of things that I have to do for fixing it. I'll show you what am I right now. So right now I have it so I can turn the physical legs off so I can test both. So right now there's kind of an issue. I'm not really sure what the issue is exactly with the stepping, but it's really weird. There's no friction right now, so that's also a problem. But then I can just turn it on. It's not going to be good. It's going to be worse than that. In fact, it seems like it can't even walk at all right now. But yeah. Now the legs are physical, so I can push them around and things like that. Seems like you make good progress though. Yeah, there was like... The big problem is just getting the IK to kind of work in the way that I really wanted it to be working in. And now it's there. And the body's kind of stable, sort of, but also not really. It's just like really struggles for the legs to work right now. Like at all. But yeah. I'm getting there. It's slowly getting closer. And now I just made this whole list basically that I have to do. Right, main body and physics, right. Slow and steady. Yeah. I do wish I was getting more progress, but I guess now, like, I mean, a big thing was that IK. Like, I was actually stuck in that for like 4 days. Trying to figure out what was going on. But now I'm back into my world, where I can just write GD script. Yep. One of 10 times you were finding Godot bugs. Yeah. I wonder... I guess before I stop, I'll see what the update is here. That's funny. The one hidden... Oh, it was hiding this. That's what it did. That's funny. It printed a big box that one item was hidden when it was just smaller to display the item. Mentioned this 5 hours ago. Fix the documentation for the skeleton. Well, now I'm curious. Oh, he made it. Wait, when? He made it. What? Oh, this line. Why did... Oh, there it is. Why is it not highlighting those words? This year, someone paying attention to some open source tend to skim things over. The crazy thing is, I just discovered that this, like, I'm just gonna ballpark, probably like over 1,000 lines of code were submitted like at one time for IK. Like the whole IK was written by one guy. Which for one is crazy, and two, I can't really blame him for these weird things, I guess, if you're doing like all IK at once. Space is created by rotating the O's. The bone pose refers to the pose immediately before IK pro. Okay, yeah, that's... The thing that I got, though, is that... I don't know if I should mention it. But I think it's more that the mutable bone axis... I don't know. Whatever. Reactors, if it works, ship it, don't ask why it works. Yeah. Fortunately for me, all I had to do was change like one line from O's to rest. Like a single word, and it was fine. I did have to turn on some other things to make it really work. But those were... The code change was just like 4 letters. Yeah. Well, that's it for me today. I am done. I'll be back tomorrow to start Friction. Yeah. I don't know. I feel like... There's nothing. It's nothing. Yep. Thanks for watching. I'll be back tomorrow. Goodbye.